On September 3rd, 2017, something happened. Seismographs all over the world started lighting up, picking up a tremor that just seemed impossible. But you know what? It wasn't an earthquake. It was North Korea detonating a nuclear bomb. This is the story of how a nation, a country under every sanction and blockade you can imagine, pulled off one of the most complex and frankly terrifying technological feats in modern history.
And look, this wasn't just any test. The energy that was unleashed was absolutely staggering. We're talking more than 10 times the power of the bomb that leveled Hiroshima. In that one moment, that single event shifted the entire global balance of power. It was proof that North Korea had just joined the world's most exclusive and most dangerous club.
So where are we today? Well, current estimates suggest North Korea now has around 60 functional nuclear weapons. 60. Which brings up the big question, right? How? How on earth did they manage to build an entire arsenal pointed at cities around the world against all odds? Well, the answer, believe it or not, starts with something that looks a lot like worthless driveway gravel.
Yeah, the whole journey to building a nuclear bomb, it all begins with mining raw uranium ore. And it's a surprisingly boring-looking rock. Seriously, it's the kind of thing most of us would walk right past and not even think twice about. But locked inside that dull stone is the seed of just unimaginable power. The process itself is just brutally industrial. First, workers take that ore and they crush it into a super fine powder. Then they dump it into these massive vats of sulfuric acid. After a little bit of chemical magic, what comes out the other side is this bright yellow powder called yellow cake. It might look like cake mix, but this is the raw material for a nuclear weapon.
Now, to really get the fundamental problem North Korea was facing, you gotta know that uranium basically comes in two main flavors. You've got uranium-238, which you can think of as the boring, stable, older brother. It doesn't really do much. But then, you have uranium-235. That's the wild, unstable younger brother. If you hit a U-235 atom with a neutron, it splits violently and releases immense energy in a chain reaction. And here's the real kicker. In natural uranium, for every 1,000 atoms, 993 of them are the useless U-238. Only 7, just 7, are the explosive U-235 you need. It's like trying to make a gallon of orange juice from a giant fruit basket that's 99% apples. It's an insane challenge.
See, to make a bomb, you can't work with 0.7%. That's not going to cut it. You need the concentration of U-235 to be over 90%. So, faced with this nearly impossible task, North Korea didn't just choose one solution, they chose two. They basically decided to either transform the boring atoms into something new and explosive, or figure out a way to separate the explosive ones out. Their first path sounds like something out of a medieval fantasy story. It's basically modern-day alchemy. Inside their Yongbyon nuclear reactor, they figured out how to literally transform one element into a completely different one: plutonium. Okay, so here's how it works. Inside the reactor, you've got neutrons flying everywhere. When one of those neutrons slams into a boring U-238 atom, the atom just gobbles it up. For a moment, it becomes unstable U-239. Then it quickly decays into another element, neptunium. And then it decays again into plutonium-239, a man-made element that's actually even more potent for bombs than U-235. But here's the thing, timing is everything. It's like baking cookies that could vaporize a city. If you pull the fuel rods out of the reactor too soon, you don't get enough plutonium. But if you leave them in too long, well, the plutonium-239 starts absorbing more neutrons and turns into plutonium-240. That's an unstable isotope that can cause your bomb to detonate prematurely, what they call a fizzle. And once they get the timing just right, they face a whole new nightmare, getting that plutonium out of the intensely radioactive spent fuel rods. This is done with something called the Purex process. Involves dissolving the rods in boiling nitric acid and using this special mixture to chemically pull out the plutonium atoms. It is, without a doubt, one of the most dangerous and toxic procedures in all of industrial chemistry, period. So while one team was busy playing atomic alchemist, another team took a completely different approach. This path wasn't about clever chemistry, oh no. This was about pure, brute force engineering. The goal was to physically separate the slightly lighter U-235 atoms from the slightly heavier U-238 atoms. And their solution? Spinning them at unimaginable speeds. First, they have to convert that yellow cake into a gas. Then, they pump this uranium gas into thousands of centrifuges, each one spinning at a mind-boggling 90,000 revolutions per minute.
To put that in perspective for you, your washing machine's spin cycle, that hits about 1,000 RPM. A high-performance car engine, that redlines around 6,000 RPM. These centrifuges are spinning 15 times faster than that car engine. And at those insane speeds, the heavier U-238 gas gets flung to the outer wall, while the slightly lighter U-235 stays a little closer to the center. But here's the crazy part. A single centrifuge barely makes a difference. It only increases the U-235 concentration by a tiny, tiny fraction of a percent. So what do? You connect thousands of them together in these long chains they call cascades. The slightly enriched gas from machine 1 becomes the input for machine 2, and so on, all the way down the line, until they finally reach that 90% weapons-grade concentration. So after all that incredible effort, North Korea finally has its fissile material, either plutonium-239 or highly enriched uranium-235. So they're done, right? Not even close. Having the fuel is like having gunpowder without a gun. Now comes the really hard part, turning that metal into something that actually goes boom. The key is you have to compress that sphere of plutonium or uranium with perfect, absolute symmetry. To do this, engineers surround the nuclear core with these precisely shaped conventional explosives called explosive lenses. And just like the name sounds, instead of focusing light, they focus the shockwave of a chemical explosion inward, crushing the core into a supercritical state. Now, the timing required for this to actually work is, well, it's almost incomprehensible. Every single one of those explosive lenses has to detonate at the exact same instant. And the margin for error here is about 1 microsecond, 1/1,000,000th of a second. Just think about that for a second. A microsecond is the time it takes light, the fastest thing in the universe, to travel the length of 3 football fields. If any single detonator is late by more than that tiny, tiny window, the compression is uneven, the nuclear chain reaction fails, and all you're left with is a dud. An incredibly expensive, highly radioactive mess. Mastering this kind of engineering is one thing, but let's be honest, a bomb sitting in a lab isn't really a threat. The final piece of this puzzle was proving it worked, and then building the systems to deliver it, well, anywhere in the world. And their learning curve, it has been terrifyingly steep. Their very first test back in 2006 was less than 1 kiloton, basically a fizzle. But by 2017, they had progressed to a device estimated at up to 250 kilotons. That's not just improvement, that is an exponential leap in destructive power. And to make the threat absolutely credible, they also mastered long-range delivery. They developed the Hwasong-15, an intercontinental ballistic missile that is capable of hitting any target in the continental United States. And on top of that, they've also developed submarine-launched missiles, which gives them a hidden second strike capability that's nearly impossible to track. So, let's just recap for a second. An isolated, sanctioned nation dedicated about a quarter of its entire economy to achieve the impossible, building an arsenal of roughly 60 nuclear weapons. They mastered atomic alchemy, brute force engineering, and split-second physics. This incredible and terrifying achievement leaves us with one final, very unsettling question.